Welcome to the second part of our PHP and MySQL and PDO lecture. So recall a few lectures back, pretty much when I was talking about forms, how we had to worry about HTML injection, and the whole attack vector for HTML injection is if the user's typing something, can they type something that itself sort of messes up your HTML, like a double quote to close a something, and if you mess up, then you actually the data that you type doesn't show up, but it escapes. And simply printing out bold die, that's not really what most people are trying to do when they're doing SQL injection. They're trying to take over browser and take advantage of your cookies and doing things with your cookies. And so if you recall, we had this thing called HTML entities, which take care of that. And again, here's how we put this double quote in that finished this value and finished it with a less than. Right? So this blue is what we typed, and this looks like valid HTML as a result, and then we take over, and then we are typing HTML in the browser, which is basically the problem. And so SQL injection is sort of the equivalent for SQL. It basically takes situations where we're concatenating SQL together with a string, or combining our SQL with actual data that came from the user and just putting it together, and then the user can take over the SQL. And so here's a bit of code, and the problem, of course, is when you're concatenating things together. And the danger is you should always be suspect of any data that can come from the user. And so this is written in a way that's trusting that the user is going to be nice and not say bad things. And so here's a bit of code in this login thing. See if you can sort of guess in your mind where the bad lines are going to be. So I'll just not tell you where the bad lines are, at least not right now. So let's actually run this code. So here's login 1. Let's take a look at our users. We've got a couple of, clear. Let's see, csev@umich.edu with a password of 123. So I'll type csev@umich.edu and a bad password, and I'll press login. And it says login is incorrect. And then I'll do the same thing, csev@umich.edu, and I type the right password, and I press login, and it says hello, and then I press log out, and I go back to login.php. Okay, so if I take a look at this code, real quick, it's pretty straightforward stuff. I mean, I have a post code at the beginning. I have a select statement. I do a query with that select statement as I concatenate the email and the password, and then I echo that stuff, and if I get a row, I log them in and set the session to be their name, and away you go. So it's a pretty straightforward login form. But let's take a look at what sort of can go wrong. Here's a comic, and I'll give you a minute to read it. So the trick to this, just like the trick in the HTML injection here, is this single quote. So so this lady and her husband cleverly named their child Robert single quote drop table students semicolon. And of course, we hope that you've learned to sanitize your database inputs. This was a much worse problem with the MySQL underscore code, and there was this like really bad feature in PHP called strip slashes. It was a bad idea. Now that we're at least PHP 5.5, that idea is gone, but it was sitting there for a long time, and it just made things really miserable inside PHP for a very, very long time. And it was a bad attempt to fix this problem, and it fixed it completely the wrong way. So that's not good. So it actually caused far more problems than it fixed. So here's the problem, right? The problem is that I've got this really clever little double quoted string that goes from here to here, and I'm using $E and $P to effectively take the post data straight from the user, and put it right into MySQL. Okay, and so let me show you how I can mess this guy up. Okay, So let's say csub@umich.edu is my account. Okay, so if you look where I'm putting that password, I'm going to have the password be, that's already in my type ahead buffer. So this is going to end the one thing, well, we'll see it in a second, and I'm going to add an OR clause, but now I'm actually in SQL, and I'm saying OR quote 1 equals quote 1, and then you'll see that there'll be a quote added. Okay, so I don't know what the password is, but I typed this as the password, and I can log in, and so you can see what happened was, this is what I typed. That part right there is what I typed into the form, but now if we back off, this looks like a fully, to SQL, this looks like a good string, this looks like an OR statement, this looks like a good string, this looks like an equal, and that's equal 1. And so what happens is, because this is OR, 1 equals 1 is always going to be true. And so for example, I don't even know what Sally's password is, but I can say Sally at umich.edu, and then I can put this in for Sally's password. Oh, and then it finds hello Chuck. It finds the first record, but I'm logged in. Okay, so you can see how I can attack this. Oop, that one didn't attack, but you see the attack vector. So the question, of course, is how do we deal with eliminating the attack vector? Okay, and like I said, the earlier MySQL libraries were really bad at this, but we're using a pattern that I encourage you to always use if there's any data coming from the user, a pattern called prepared statements. Prepared statements. So sometimes you've seen me see PDO query, and sometimes it's PDO prepare and then execute. So sometimes I do it with a one line, a single line, like PDO query SQL. That's fine for certain things, but it's not fine if you're actually substituting data. If you're just doing a query, you can do PDO query. But far more often, we are actually substituting something. So we do this two-step statement, prepare query. And we use what I showed you before, these little placeholders, :em and :pw. And then we have the key value pairs that map. And then this is now, the post is the user entered data. And when the SQL actually executes, PDO fixes it. It expands all these things, puts the right stuff in, but it properly escapes it in a way that no matter what the user types. So this is a safe way to do this, because the user can't like put an extra quote in or anything like that and escape out of the SQL. So the answer is never concatenate with user data. Always make a prepared slot, always do a prepared little placeholder, and then send it in with the two-step prepare and execute pattern. That protects you from being corrupted by SQL injection. So while we're looking at errors, let's look at some other ways that you can have things go wrong and the kind of messages that you can expect when you make a mistake of one form or another in PDO. So let's take a first look at this one that doesn't have an error, this error 0.php. So let me bring that up. So here's error 0.php. I give it a ID equals 1, and I run it, and it says ID found. So if we just take a quick look at how this works, I just throw a get parameter. I'm really lazy here, and then I'm going to say warning, and it's going to take that ID, have a placeholder XYZ, read the get parameter, and then check to see if I got a row or not, kind of like a login thing. I either didn't find it or I did find it. And so the success is whether or not that ID exists. And so if I take a look at, if I change this to ID 100, which is not in my database, it says not found. If I say ID equals 2, it says it found it. So some it will find, some it won't find. And that's what this little program does. I'm not really interested in the program. I want to show you what happens when you make a mistake. So let's make our first mistake. So our first mistake is I'm having a placeholder named XYZ, XYZ, and then I don't have a placeholder that is XYZ. I mean, you're supposed to have the same number. If there's 3 placeholders, you have to have 3 elements in this array, and the keys have to match. Well, this one doesn't match. So that means that something's going to blow up. So let's take a look at what happens when this blows up. So this one's called error 1. It's our first little error. So error 1, it blows up. We told it to do a warning. And so if you look at where it's going here, when it's starting to blow up, it's like invalid number, parameters not defined, blowing up on the execute twice. It blew up twice on the execute statement, but it did a warning, and so it kept on going, and so it failed, right? It said ID not found, meaning it didn't stop. It just kept on going. And so that might be what you want. That's kind of sloppy in a way. You could check all of those return codes for errors if you want. You could do that. But let's take a look at the next one that's a slightly different one. There are several things that you can do in terms of configuring your PDO. You can tell PDO that you would like it to be silent on errors and that you will just check all the errors when they return. You want it to, you'll check errors on return and you want it to be chatty. Or you can tell it to throw an exception. And then you're supposed to put your code in a try-catch block. And so I did error mode warning, and you saw the big warning messages coming out. Okay? So here's that code. If we take a look at what's going on, you see that I've told it I would like a warning error. And that's really telling it how to behave in each of these situations. That says, be rather verbose as to what's going on. Give me errors. Of course, you have to have errors turned on in general. But because it's a warning, it didn't actually fail. And so it continued. It didn't get the row became false. And so it says ID not found, even though in this case, ID equals 1 was present in my database. So now I'm going to play a little bit with the error mode exception. So if you change error mode exception, only change the program, says, look, I want you to give me a message, and then I want you to blow up and not continue. And so this basically puts out an error message, and it blows up, and it gives you a traceback. And it tells you that you're at line 9 of the code, and yada, 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 and says the parameter wasn't defined. It's the same kind of messages, but the difference is it doesn't execute any of this code because it really dies right here at the execute. Yeah, it's the execute where it dies. And so you have said, hey, if I make a mistake, some kind of a syntax error, stop now, blow up, put out traceback, absolutely quit. Okay? Now the next thing that we'll do is, actually you're not supposed to just let it die generally with a traceback. You're going to encapsulate this traceback in a try and accept block. And so we add the try at the beginning, try catch block. And this basically says, if it goes well, run the code and continue on. If things go well, runs this, runs this, runs this. If things go well, you continue down here. If, on the other hand, it comes in here, goes badly, it blows up, it jumps down here, and EX is a bit of an explanation as to why things went wrong, and so we'll pull out the actual message, and then we'll return, and so we'll never continue down here, but then we have a lot more control over what the error looks like. And so there's a whole bunch of other things. You can check the return codes to prepare, etc., etc., etc. And so the error checking on this is very, very flexible, but you do have to take some responsibility as a developer. Another thing that you can do, if you think about it, you know, the user here is sitting, when we're developing, the person sitting at the application running things, and you are the same person. But sometimes this person is the end user. And so they might be seeing exception messages, but they're not going to tell you what they are. Are they going to take a screenshot? And so sometimes you want to put out what's called a log message. And so your application is spewing log messages off, and you can watch them. And even if something goes wrong, sometimes you don't bother showing the user an error message or some really generic smiling error message. But then you want to log all the detail. And there's a function called error log inside of PHP that allows you to do that. So the only thing I'm doing different here is I'm doing the error log right before I do a return so we can take a look at that. So if you want to see where those logs are at, you can look at your PHP-Info and look for the variable error_log, and it will have a very long path. And if you hunt on your hard drive for where that path is, then you will know where to go find that error log. And here's just some examples. If you're running MAMP on the Mac, we tend not to run XAMPP, but you can do that on the Mac as well. If you're on a Windows, you're generally running XAMPP, and you go into this folder. You can just open in the text editor, like Text Wrangler, or you can do in a window where you're actively watching the log. This is easiest on Linux because they have this command built in, tail-f file name, and it shows you everything, and then it stops and waits, and then every time a new log entry comes on, it shows you dynamically. So you just kind of keep that running in a terminal window all the time. And in the Windows, there are equivalent things. You can just look for Windows replacement for the tail command. This mtail was one that I played with. It seemed like it had the least amount of ads and other kinds of stuff. And so if you were to take a look at the tail of this log, I'm using MAMP on this particular one, and I say I'm in the right directory. So I'm in the right folder here, and I say tail-f PHP error log, and you can see that I've been testing lots of things that are going wrong. This was, yeah. So you can see, well, you can see when I was testing, which one was I testing? I was testing error 2, and then I was testing error 4. And so error 2 was blowing up. Error 3 was silent because I was catching it and putting it to the screen and not doing anything. So there's no error 3 in here. That's kind of a bad thing. But down here in error 4, I caught it. I said something reasonable to the user screen, and then I logged this data about what was wrong. And that is going to make a lot more sense to me than the user. So you give the user some kind of a generic message like something went wrong, and then in the log put all the detail. It's also probably a good security not to reveal too much about what's broken about your application, because that might become a point of potential exploitation. So this notion of catching your errors, putting out a log, and then not putting all the errors to the user screen is not a bad is a pretty good strategy.